Welcome to today's webinar. I'm Olaoluwa Adedayo. I'm a business analyst here at Secure Intelligence Limited, and I'm your host on today's webinar. But before we proceed, I'd like to help you interact better with this platform, as this might be the first time most of us might be interacting here. So just below the screen, you see a tray like that contains icons. These are icons you can use to interact during the webinar. You will see a Q&A icon. This will help you ask questions and get feedback in real time. You see polls. Please participate in the polls I will be churning out during this webinar. This will help us serve you better. You see reactions. You can engage with the speakers as during the webinar with your reactions. We are all here for it. So moving on, our topic for today's webinar is how to build secure and scalable solutions with AWS. And our use case for today is Playshaka. Playshaka is a digital solution built by Secure Intelligence Limited. Today, we'll discuss the idea behind Playshaka. We'll discuss the solution. We'll discuss the architectural diagram, and we'll demo Playshaka for you. But moving on, I would like to tell you about who we are at SEAL. SEAL is Secure Intelligence Limited. And at Secure Intelligence Limited, what do? We help bring ideas to life. We help bring your ideas, we help bring it to life. We make your ideas, we build products, we build solutions from your ideas. We are an AWS partner that simplify and build cloud solutions for enterprises at a global scale. We help companies and enterprises adopt cloud solutions to drive agility and growth for their businesses. Moving on in today's webinar, my colleague will be speaking to you on the Playshaka itself. My colleague will help you understand the idea of Playshaka, and my colleague will walk you through the solution of Playshaka. Allow me introduce Mutiat Olariwaju, our data engineer here at Secure Intelligence Limited, to take it from here.
Okay, thank you, Olaoluwa, for the introduction, and thank you for walking us through why we are here today and who we are at Secure Intelligence Limited and what we do. Just like what Olaoluwa has said, we will be discussing what gave birth to Playshaka, what's the idea behind Playshaka, how we're able to develop Playshaka, what are the strengths of Playshaka, and what we are able to achieve while building Playshaka. As an AWS partner that develop solutions, one of our clients wants to build an application that connects everyone to diverse African content. He just doesn't want this application. He wants application whereby the users can actually have access to different African content. And what content are we talking about? It can be, we are focusing on entertainment. It can be news, it can be radio, it can be music, it can be game. Like, it doesn't want people to keep moving around from one application to another. I want to read about sports news. I want to listen to radio. You need to move from one application to another, because you can't get that one-stop application that serve you all that purpose. And these our clients want all these in one application. And it just doesn't want this application. There are some requirements, there are some criteria that it wants this application to meet up with. You want the application to be secure, you want the application to be fast, to be scalable, and all this has to should not cost us much. You want the application to be cost effective. Like, we have to put costs into consideration in any solution that we want to come up with. We as Secure Intelligence team, we actually gather together and how can we build this application? How can we build on this idea? How can we make it come to reality? Then we realize that it's best for the application to be a multi-tier application, whereby we'll have the presentation tier, the application tier, and the data tier. And the presentation tier is just like the user interface that allows the user to interact with the application. That is where you have access to all the content. That's where you have access to the news or the radio that you want to listen to. That's the presentation tier. The application tier, the application tier will be the backend services that handle all the logic that provide the requested content that you want. Imagine that maybe you want to listen to music now. It is where how the music will be fetched to you, how you'll be able to get the music. All those logic are in application tier. All those logic will be done in application tier. And the data tier is which consists of the database that will store all the information, that will store all these contents. And that means that all the content will be coming from the data tier. This is just like the overview of how the application works. But what are the AWS services? Since we are AWS partner, what are the AWS services that we're able to use to bring this Shaka into life? You might just be looking at the screen and like, what's all this? Just hold on, everything will be like, you get everything in short time. Right off the bat, we're talking about getting access to African content. Definitely we'll be dealing with a lot of data. Where do you think all this data, we need to consider how this data will be stored and where all this data will be stored. And that is why we'll be needing database. Not just only database. One of the ways to optimize cost is to choose the correct database for your use case. So we need to consider those requirements. Don't forget that we have some requirements that this application needs to meet up with. We need to consider those requirements. And a tip for cost optimization for compute and database is to use managed services, because with managed services you don't need to run any server. You don't need to consider managing any server or infrastructure. And that is why we have DynamoDB used for our database. DynamoDB is a fully managed NoSQL database service. It is very fast and flexible. It can handle large amounts of data at a very low cost. Don't forget that one of our keywords is the application should be cost effective. And that is why DynamoDB is being in use. We also said that this application will have different content. So we need to manage content from multiple sources. We need to get content from different service providers. How can we now have access to all this? How can we manage all this content that we get from different service provider? And that is where AWS AppSync comes in. This is also a fully managed service. It makes it easy to develop GraphQL API. With AppSync, we can build an API that securely access data from multiple sources, even including DynamoDB. We need to run code for this application that we are building, and that is where AWS Lambda comes in. With AWS Lambda, you don't need to be thinking of managing server, you don't need to be thinking of managing infrastructure. And one thing about AWS Lambda is that it scales automatically. You don't need to do anything to actually make it scalable. And with AWS Lambda, we can write serverless function that can be triggered by events. Sorry for the background. So moving forward, we have API gateway here. With API gateway, we can create, maintain, and secure API at any scale. You might be wondering the difference between API gateway and AppSync. API gateway actually make it easy to create a RESTful API that is backed by Lambda function. Hold on a minute for me. Okay, sorry for the interruption. Like I said, with API gateway, we can create, maintain, and manage API at any scale. And this makes it easy for developers to actually monitor the API, and this API is also secure. We need to manage user because we want user to visit the application and use it for their purpose, and that is where we'll be needing AWS Cognito. With AWS Cognito, we can create a secure, scalable, and cost-effective authentication and authorization that can actually be integrated into the application. Because when you come to the application, when you want to use the application, we need to know who can have access to the application, what content can you have access to if you sign in or without you signing in. We need to put all this into consideration. With all these services that we have here, we realize that putting all these services together and considering what our clients want to meet up with, we see that these services are the key one that actually best fits our use case. But how are we able to integrate all these services together to actually build Playshaka? Are you wondering how? Can you give me a thumb up if you are interested in knowing how we're able to integrate all these services to build AWS, to build Playshaka? Like, you may be wondering, like, okay, DynamoDB, can it work alone? AppSync, how are you able to use it? This, that. Then that would take me to the Playshaka architectural diagram. But at this point, I'm going to hand over to James, our solution architect at Secure Intelligence, to walk you through the technical aspect of Playshaka, and you will be wow, like, oh, is this what we're actually doing in Secure Intelligence Limited? Thank you.
Everyone. Good afternoon. I'm James, and I'll be walking you through the architectural diagram of Playshaka. Before that, I would like you guys to have a look at this architectural diagram. If you have any questions, you could always ask me after the session. I think there's an option for that, for dropping questions, so please go ahead. On this architectural diagram, I'll be going through two phases. The first part, right, I want you to have a look at the users part by my left side. You can see users, right? Users visit Playshaka using their various devices. Devices could be a desktop, could be your mobile, could be your tablet, your laptop, as the case might be. When you visit Playshaka, the first point you hit is an AWS CloudFront. That AWS CloudFront actually displays the site for you to see. It brings the site closer to particular users. It's a content distribution network, rather a CDN network service for AWS. That's what they use to distribute the various websites we see. Where is this website stored on AWS? The website Playshaka, in this case, is actually stored on an S3 bucket. That's the web application you're trying to see, right? It's a static content, the HTML, the images and the likes, right? The CSS. For those of you that are a little bit technical. For those of you that are not, it's just basically a bunch of text documents and the likes, where those words you see on the page, right? Those words you see on the website, that's what you see. That's what static content means. Now, before going further, I would like to talk about APIs a bit. APIs are just what you use to call data from the database. Any website you go, the data you see there is just like basically an API call, right? various form of APIs. We have REST, we have GraphQL. In this case, we're using a form of GraphQL, an AWS service that actually provides GraphQL. That's AppSync. You can see the arrow there from the CloudFront distribution actually leading to the AppSync. Now, the static content you actually see on the page is displayed by the S3 buckets. But those static content are just there. What actually populates those contents, what's fill it up? Those things comes from the API calls, right? And what takes care of the API call is from the AppSync. As you can see, right, the AppSync is directly connected to the database. The database in this case, like my colleague mentioned, is a NoSQL database. That's DynamoDB, scalable, fast, flexible, and the likes. So when a user comes to API, comes to Playshaka, you want to listen to music, you go there, you play music. You want to watch videos, you go there, you play videos. You want to read news, you go there, you read news. All you're just doing is you're interacting with the CloudFront distribution, that is with the static site, and the data that is actually filling up that place is coming from an AppSync call, that is a GraphQL call to the database. You understand? So on that, right, let me take you to another aspect of the interaction. So for you to know that Playshaka is actually very dynamic, we implemented it in a way whereby users that are not registered could actually come and play around. They could listen. You don't really need to register. But now, what if you're a constant user? You want to come here every day. You want to actually read news every day. But you want to read the news from specific countries, like from India, African countries rather, from Ethiopia, from Kenya, South Africa, and the like. You don't want to be looking for those particular news every day. You just want them to know. Anytime you come there, you want to know, okay, they are there. You want to see, okay, this is only what I want to see, news from South Africa. How did we implement that? Now we have what we call IDPs. IDPs are just basically identity providers, right? You know, when you go to a site, you actually have to fill up a form. What's your name, your surname, and the like. We don't want all those long processes. We just want you to come and enjoy yourself, interact with the whole website. That's what we want. So we took care, like my colleague mentioned, we took care of authorization and authentication using Cognito. Cognito actually allows you use single sign-on options. That is, if you go to Playshaka, all you just have to do is sign in with Google or sign in with Facebook. You don't fill any form, you don't write your name, nothing else. Then basically you could tell us, okay, you select, I want South African music, I want Nigerian news, I want radios from Kenya. Then we save it. As you can see, the IDPs are actually very easy, connected to Cognito, which provides authentication and authorization, then makes a call basically to the AppSync. So now when you tell us, I want news from South Africa, for example, we store that preference, we store your particular preference. If you look down, just at the down of the diagram, you can see there's a couple of tables there. The tables actually include cookies, preferences, logs, and trends. I will explain a bit of them. Okay, for a very good example, now you click on South Africa. What we do is we store your preference in the preference table, in the preference database. Okay, trends for today. We want to know what's trending, what kind of music users are listening to, what kind of news user likes reading, what kind of news user has interacted with the most. Those are the trends, right? We store the trends in the trends table, as you can see. We take care of your whole interaction with the application. Now, those are done. That is done actually using an API gateway. You can see the Lambda resolvers just actually help us collect the data from the AppSync, pass it through an API gateway, and save it in the database. Now, for a very good example, a very good use case, let's just say, as a user, you want to see a particular news, let's just say news from South Africa. What we will do now is we will get the data from the database. You already know your preferences. You come in today, you read news from South Africa. Let's just say you come back tomorrow again. You don't want to go through selecting preferences. What we do is we pick your identity, that is, we pick you from the preferences table, we pick your preferences, then we sort the preferences from the other table, that is the news table, as the case might be now, from South Africa. We use AWS Lambdas for that. As you can see, the AppSync is connected to the Lambda. The Lambda actually does the manipulation. Lambdas, like my colleague mentioned, are just basic for computing. You don't want to write, you want to write a function. You don't want to stress out on my system is too slow. How long will it take for this function to run? AWS takes care of that basically. All you just need to do is go there, write your function, and boom, everything is done. Everything is done with. So we make use of lambdas for, in this case, right? We make use of the lambdas for the manipulation of data, from the various manipulation of data. We also make use of cloud search for searching functions. You go to cloud, you go to Playshaka, you search for Whiskey, it comes up. Now we don't want to go through the stress of writing the whole logic of, okay, I want you to go to this table, pick Whiskey for me. No, we don't want to go through that whole stress, right? All we just want to do is we just want to see news from Whiskey. AWS has a service that actually takes care of your search for you. It is called a cloud search. It's called AWS Cloud Search. You understand? So all you just need to do is connect it to your database. Immediately it's connected to your database. You pass your search query to it. It returns you what you want, as you can see in this case. But now we've been talking about the data from the music table, from the news, from the TV, the radio, and the likes. How do we get this data? Where do we get this data from? This data is basically gotten from the web, various sources on the web. You can see the scrapers, right? If you notice, the icon on the scrapers is still the same as the icon on the resolvers. Those are still the same Lambda functions. You understand? So basically, Lambda functions run scripts, anything you want it to run. They will even run microservices, as the case might be. They are very, very dynamic. So what the Lambda function does in this case is it goes to the internet, it fetches data from the internet, and it saves the data in the database. The scrapers per se goes to the internet, fetches data from the internet, saves the data in the database. On Playshaka, we have over 1,000 Lambda functions, just each of them working independently, which means if one goes down, it doesn't affect the other. It's of no concern to the other. The rest are actually working quite fine. So if you have a look at it, we all know that news comes out daily. Not even daily, news comes out like minute by minute. A minute, you're hearing one thing, and that minute, and that thing has come up. That's news. That's day-to-day life for you. You understand? How do we do this? Do we say, okay, because now we know that news comes out every minute, is it that every minute we go there and run that function so that it will go and fetch what is in the internet or what is in the web per se now and store it in our database? No, we don't need to go through that stress. Or do we have to actually run a cron job? A cron job now is a scheduler, right? Where you have to walk through the whole aspect of, okay, I want you to call this function every 15 minutes, or I want you to do this every 15 minutes. Every 15 minutes, go to the internet and fetch what we want and put it in the database. No, you don't actually need to go through all those stress. AWS has a service that actually takes care of that. It's called an event bridge. So basically, in event bridge, you just create rules. You create a rule for the scripters, for example. Let's just say, okay, every 5 minutes, I want you to run automatically, go to the internet and fetch the data from the internet and store it in the database. You understand? So basically, these are the various services on AWS we're able to combine to actually bring Playshaka to life. As you can see, they range from 7 to 10 various services, all connected, all doing different purpose, and all working together as one, even though each are microservices on their own. Each are individual microservices. I hope you get this explanation and don't ask me too much questions. But basically, if you have any question, you could go ahead and drop them in the question box. While I pass on to my colleague, I'll be able to answer a few of your questions. I hope all, as the case might be. While I pass on the presentation to my colleague, Cousin.
Thank you very much, James. Thank you very much, Mutias. Thank you very much, Alalua. I mean, I think I'm dumbfounded already. What can I say? You guys have said it all. Thank you guys so much for your insight. I think I've learned one or two questions, but I think the first thing is we want people to ask their own questions, and also please, the polls are there. You guys can participate in the polls. Just want everybody to please participate in the polls. Please participate in the polls. So if you have questions, kindly put your Q&A. Just check below. You'll see the Q&A close to the attendees. put in your questions, and we'll be taking your questions shortly. Yeah, so on a side note, Playshaka is actually very dear to me because Playshaka was like my first project, like when I got to SEAL. But one very interesting thing about Playshaka is this. Every single person that worked on Playshaka came from the SEAL Academy. Is that not fantastic? Every single person. Can you guys hear me? I think somebody is saying that they cannot hear me. Can you guys hear me?
We can. Yes, we can. Please go ahead.
Okay, probably. Okay, cool. So every single person came from SEAL Academy. So, and SEAL Academy is currently running now. The internship is running, and we already have 10th. I hope you guys are enjoying it. If you guys have joined us here today, kindly give us thumbs up. Because in a couple of months, you guys will be building this fantastic thing that you are seeing here. So if you have questions, kindly put your questions in the Q&A. I can already see you guys contributing loud and clear. Okay, so let's take the questions. So the first question is from John. He says, please, what's the difference between AppSync and the API gateway if they are both managing APIs? Can you please answer that for us, James?
Okay. Hello, John. That's a very interesting question. So like I mentioned initially, right, AppSync is a form of a GraphQL API. What AppSync does basically is GraphQL. And you can take your time later and read on that. I'll explain a bit more. Why what API Gateway does is basically a form of REST API. You can see those are actually two different forms of API. Each form of API is optimized for various reasons. AppSync is optimized for faster queries. What I mean by faster queries is you want to see your result almost at an instant, right? You're not doing that much of a write function. You're not putting into the database that much. That's what you use AppSync for, basically. You understand? So when you want to see, okay, very faster results, you just have to use probably, and you don't want to overfetch your results. You want to use the same endpoint for multiple results. Just if you play around with GraphQL, you get to see things like that. Basically, that's what AppSync does. Why API Gateway is a form of REST API where if you want to actually write and interact with your database more, like write and read, like it goes both ways if you get what I'm trying to say. So if you want to write and interact with your database more, you get to use the likes of API Gateway, REST API. I hope this like gives you a little bit insight into that.
Okay, thank you very much, James, for your answer. John, please let me know in the Q&A if the answer I gave was very okay for you. Now we have another question here which says that we learn all these at the same time. Definitely not. It's not like I'm going to learn everything at the same time, but it's one step at a time. I believe that you can, we all can learn at our own very pace. So you can learn it one step at a time. So somebody says that they can't. Okay. I think we've answered that. Okay, now somebody is asking another question. I think this is from Patrick. He says, when the scrapers get the data from the web, when and how does the old data get cleared? Or is data stored permanently after being scraped? You want to answer this, James?
Okay, so yes, on the matter of does the old data get cleared or is the data permanently stored? When the scraper gets from the web, it stores in the database. We don't delete it basically for various reasons. Let's just say, for example, a user wants to see very old news of a particular, very old news per se. What all the research you're doing is actually in tune with a very old news. You could still go there and search the database to give you something from probably a year ago, 2 years ago, that is still stored in the database. It doesn't get permanently destroyed. We don't destroy our data per se, we store them. And another thing you should note that DynamoDB is actually not expensive per se. You get to store very large amount of data for very, very little cost. When I mean very little, very minute and almost inconsequential cost. So with all the use cases, it's actually more preferable we actually store the data. And lastly, we would we actually do some form of like machine learning on the data, right? Whereby if a user comes in and you tend to listen to this kind of particular kind of music over time, right? That's what we just offer you. You come in, you listen to Afrobeats and you like searching for Afrobeats. We don't want you to come in next time and say, okay, although my preference is like Afrobeat, we run machine learning models where we get to know, okay, this is the kind of things we know you would like, then we offer them to you. So you see the use of old data. Old data is actually also used to train our models to let them our models know what users like. So we don't permanently destroy our data. And I hope that
All right.
answers your question.
Okay, please kindly let us know if that answers your question. Thank you very much, James. Just to add to it, I'll just say something. They said data is the new oil. And when you have data, you know what you can do with it. You can do your historical analysis with it. I won't say more than that. But let me delve into it. So there's someone here. The person is asking, why was EC2 not used?
Why wasn't EC2 not used? I think it's a bit fancy. Okay, before we get into why was it not used, I would also like to mention that I'm a solution architect, right? The whole reason for having solution architects on a project is to think of the easier way to do things, the cost optimized way of doing things, the secure way of doing things. Is this one necessary? And EC2 could be used basically, but is it necessary? Do you want to just waste money on that aspect because okay, it's the fancy data stuff, it's the fancy stuff to use? If we could provision this using these basic services I mentioned, these basic services you could see on the architecture, why use an EC2? EC2 are actually more expensive than all these combined. I think probably like in upcoming slides, you could see how, see, on Playshaka, I believe the lambdas we actually have on Playshaka are over probably 1,000, maybe over 1,000. I don't know. I'm not, it goes so much to an extent we stop keeping tracks. We just like keep on provisioning things we needed. You could see probably like in the next slide where my colleague will show you the cost of all this together. Be wild about the cost of provisioning using multiple services like this and the minimal cost of them. Probably from what you can see, you see probably maybe $500 or maybe as the case might be. In the next slide, you get to know why EC2 is not used. So basically, a solution architect is to see the optimal way to do things that is less cost, that won't eat deep into your pocket and will work quite well to what you want. EC2 could also be used if you want to, but then it's just quite unnecessary in this case. That answers your question.
Okay. Thank you very much, James.
Hi.
In summary, I think okay. Yeah.
Okay.
Okay.
Hi everyone. I'm Cornelia.
Yep.
I've been keeping since. I am cloud engineer here at Secure Intelligence, and yeah, that's your question. Why we didn't use EC2? It's something that I would really want to talk about. Um, First of all, cloud computing has like different use cases, and various the one of the advantages of it is that various businesses at different stages can actually use the services it offers without spending too much money. And for you to use the services, you need to know why you want to use it, what it will give you, and how much time you want to spend on that services. With EC2, you would want to start thinking about how to start patching your instances, how to install web servers in it, how to, if you want to link it to the database through the servers, it's basically setting up a full computer. But what we wanted to use the lambdas to do wasn't necessary at all. We just need a code to run. That was it. That was it at a specific time. Just do that for us. So spinning up an EC2 server or spinning up multiple EC2 servers for that feels overkill. Why do that when you could just, when there is a service that easily does that for you, and as soon as it's done running your code, it stops, thereby saving you money. So that's like one of like the few reasons why Lambda was used instead of EC2. We just needed the developers to have, should I say, to think more about their code than about the infrastructure running it. All
Thank
right.
you very much, Cornelia. You guys have heard from the pro herself. I'll be another question here. I think this is for James. Person is saying that wouldn't it be better to clear the data routinely, let's say after 5 years, and if the user generally likes a particular niche in cookies?
Okay. Quite an interesting one. Okay, I would actually want to make particular references, but let me choose of the use case in this case. A very good example is whereby the data you need for that thing is actually something of like 20 years ago. Would you have actually seen that same data if if the owner of the data that stored it somewhere in the internet cleared it? You see, the whole essence of actually having or storing data, right, is more based on for various reasons. One of the reasons is probably the cost. In your case, you said, let's say after 5 years, if the user generally likes a particular niche in cookies, machine learning models are actually trained to pick up things user does. Let's just say for a very good example, you've been doing a particular thing, right? And you now switch. You've been listening to Afrobeats, then you switch to probably like R&B and the likes. What the models are actually supposed to do is learn from your new inputs and create like new output for you. Okay, we know now that you like R&B, so we're just going to give you R&B. Doesn't necessarily mean we should delete the former data. It doesn't necessarily mean you're working on old data. You understand? And come to think of it, say you want to listen to a music of, let's just say, almost all of us here still listen to like very old music occasionally, music of 5, 10 years ago. We won't actually get to interact with data like that if they are cleared. Your reason of having a data storage, right, of having a more robust data storage, that's DynamoDB in this case, your reason of having that much robust data storage is, okay, we get to interact with the data in future times. Machine gets to learn. For a machine model to actually be very good, right, it has to be trained on a very, very huge data set. So with time, right, those data sets compound and the machine actually uses that to learn. I think on Playshaka, on the news DynamoDB, we have like maybe 8 million, 10 million each articles individually. You understand? And this is like data that have been compounding for so long. So regardless of if you as a user you're not using that niche anymore, you're changing niche, it doesn't actually affect what is there. It doesn't actually affect your own interaction with the website. The model is actually trained to be more in line with your own interactions. You understand? If
Yes.
that answers your question.
All right. Thank you very much, James. So this question now, there are two different questions, but I believe that we can merge them to one. And I think Cornelia will be able to help us do justice to this. First person asks, what is EC2? Please. Then the second question is, does Lambda serve as EC2? So I believe what you can do here is to juxtapose between the two, what EC2 is and what Lambda is, then you can tell us the difference. Cornelia, can you hear me?
Yeah, I'm here.
Okay. Thank you very much.
Okay. I think it's my fault for using the word EC2 and not actually using its actual name. EC2 is just like a name given to it. It's actually a server. And for me to answer that, you'd have to know what servers are. I would say servers are computers. Your laptop is a server. Your phone is a server. They're basically a um an equipment where you could do multiple things. There are servers that can be used for running some computations, for saving data, like storing pictures. It's just a piece of computer hardware, software that runs something. Yeah. And EC2 does that. And before cloud computing, the idea of owning a server, because you have some requirements before you can actually use said server. First of all, it has to always be on. If you want to be running computations, you don't want instances that it will go off, especially when it's at its uptime. Like I'm trying to make requests to this server now and it's down. That's like a bad server, and you even don't want to call that a server. So before you want to be able to have this equipment that does those things, it needs to fulfill the requirements. It needs to always be on, and have less, I call them distractions, that will slow down whatever you want to run on it. And to be able to have things like that used to be very expensive. Like I'm talking, I don't know where everyone is from, but in Nigeria, using the naira currency, I'm talking in the millions. You could see a few for like, I don't know, 600K, but nevertheless really expensive. But well, cloud computing came, and someone as far as me could actually have one for less than, let's just say, $1 a month, if I even, if depending on how I use it to get. So that's basically what servers are. This piece of software hardware that you could work with. um a lot of things on the internet are based on servers. Google Drive are based on millions of servers running that you could store your data. And of course, they have to be configured for you to be able to do what you want it to do. And just that configuring part is where the issue per se comes in. Sometimes you want to do something as simple as we mentioned, running a piece of function after 15, 10 minutes, 5 minutes. Do you really want to spend time working on a server, configuring it? Make sure you manage it as in patching, because um vulnerabilities can come up in servers. Like we have hackers all over the world. People want to try and break into things. So the builders of servers, we want to install security patches to it. So you, as the owner of that server, has been on ground or you're using cloud computing, AWS, you would always want to make sure you're updated in those patches. You have to be maintaining it always. And with AWS, there's something known as a shared responsibility model, in which it tells you what they are responsible for and what you are responsible for. And if you want to work with servers, you're going to be responsible for a lot, a whole lot, to maintain, updates, patch those servers, except the hardware. AWS is responsible for the hardware. They do the whole power and the rest. I'm wasting time now. All right. So those whole responsibilities that you wouldn't want if you just want to run code is where the lambdas actually come in. Lambda, it's called serverless because you get to do less of what you would do in a server. Not meaning there is no server running with Lambda. Lambda is a running server that you don't get to manage. AWS do those ones. In the shared responsibility model, you're only responsible for the code you put into the Lambda and the runtime. And that's it. That's the two difference. Lambdas, AWS takes a lot from your hand and handle it for you. Just put your code and run it. But with servers, EC2, you get to do most of those management by yourself. So it depends on what you want that server to do for you. If it's something that's, again, running code, you wouldn't want you wouldn't want to use an EC2 instance. You definitely want to use a Lambda. Or if it's an instance in which you want to put in your database, secure it, and run some inbound, outbound requests, blacklist some region from coming in, and whitelist some people, you definitely want to work with a server or containers because they give you that flexibility. So
All right.
does that answer your question?
All right. I believe that must have answered the person's question. I believe so. So thank you guys for your contribution. At this point, we just want to show you like a glimpse of what Playshaka has in store, like the platform of wealth for Playshaka. I don't know if Olaulo is still there.
Yeah, I'm with you.
Okay, can you please help me?
Sorry, I didn't get that.
Like go to the next slide. So basically on Playshaka, we have a whole lot, just like James has said, we have more than 8 million news contents. Yes, more than 8 million. You heard right. And everything we have showed you so far costs just $30,000. Just costs just $30 per month. Talking about the running cost less than this to run it monthly. So imagine that. Imagine all these services that you're integrating together, because AWS is about pay as you go. And once you factor in the necessary costs and the necessary and you're using the right services, you definitely not incur unnecessary costs. So at this point, I think I want to share my screen. If Ola can stop sharing the material, I just want to show you what the app looks like. Know when you guys can see my screen. Okay. Ola, can you? Or it's still coming up?
Yes, we can see your screen. Are you there, cousin?
Can you see my screen? These are the radio stations, popular radio stations. Then on the I am. Can you guys hear me? Hello, can you guys hear me?
Yeah, sure.
Okay. So these are the popular radio stations. These are top on Playshaka, and this is the trending. So the table you saw earlier, you had cookies. You can see these cookies here. So once you accept, we'll track that. We also have so these are the features on the side. This is stations. You can see here. You can click on anyone. See, I don't know whether you guys will be able to. Hope that was not too lousy. So this is Shaka TV. We have, you can see from sports to tourism to music videos to movies, health, fashion, all sorts. We also have the news here where you can view what is currently happening, like the elections, Labour Party, every single thing, Nigeria, but all around Africa. So yes, that is what we have for you guys today. I don't know if we still have questions or contributions. Do we also have people also participated in the polls? Please, if you have not participated in the polls, please kindly help. Then you can drop your thumbs up for us. If you still have further questions or anything at all, kindly let us know. Okay, thanks for the thumbs up. Okay, James, thank you for the answer. This is yes, thank you, James. Again. Oh, okay. I think James answered the question already. So in the absence of any other thing, I think we can draw the curtains for today. Thank you guys for coming. We really appreciate guys for attending our webinar, and we hope that you keep another date with us, like subsequent webinars. Thank you very much, guys. Mutiat, J, Cornelia, Olaoluwa, you guys have any parting gifts or anything to say to them?
Okay, don't forget to visit Playshaka and explore it. Thank you.
Yes. So
and watch out for Seal Academy, so you can become one of the developers someday and build something interesting, something fantastic, and change the world.
Exactly. Olaolu has said it all. Watch out for Seal Academy. Because we are building capacity, people that are going to change not just Africa, but the entire world. You know, can see their hands already. They are here. So it's all good. It's all good. So thank you guys for coming once again. Have a
Thank you very
lovely
much,
day.
everyone.
Yeah.
Have a
Bye.
lovely day. Bye.